Hello everyone, let's move to second chapter, which is the second order differential equations. Before we go further, let's know about the second order differential equation. Its general form is a y double prime over here plus by prime plus cy, and then we have a function in the right hand side. Okay, the second order is represented by these terms, and then the second order differential equation can be divided into two types. First, homogeneous equation, where the fx is equal to 0, and then we have non-homogeneous equation where the fx having functions. So in this chapter you have to learn how to solve the homogeneous equations and also how to solve the non-homogeneous equation using the undetermined coefficient. We will go one by one. Okay, now let's go to the solving homogeneous equations. Okay, previously, as I said to you, the function on the right hand side for homogeneous equation is equal to 0. Okay, so for example, if you have one equation, that equation is, let's say we are taking y double prime plus by prime plus cy equal to 0, and then you want to find its general solution. And then the first thing that you need to know is you need to convert this equation into the characteristic equation. So what is the characteristic equation? Characteristic equation can be denoted in terms of lambda. So you can replace y double prime here with lambda squared, and then y prime over here with lambda. You need to remember the lambda only involve the derivative terms. So you will have here a lambda square plus b lambda and then plus c equal to 0. This one as a 1 only, which is the lambda power of 0. Okay, so now you have to find the value of the lambda. Okay, since we have the power of 2 over here, so you will have 2 roots over here. So these 2 roots will determine your general solution. So there are 3 types of the roots will be covered, and then this is the general solution. The first one, if you have your root is having the different root with another one, which means that you have the different roots, so that your general solution is c1 exponent lambda 1x plus c2 exponent lambda 2x. Right. So you might have the similar root, which is your root lambda 1 is equal to lambda 2. So you will have for this one, your general solution is c1 exponent lambda x plus c2 x exponent lambda 1x. So here it's either you use lambda 1 or lambda 2, is the same one. And the last one, you will have the complex root. So the complex root is, for example, you have the lambda in terms of alpha, and then you will have plus minus beta imaginary I over here. So your general solution is yx equal to c1 exponent alpha x sine beta x plus C2 exponent alpha x cos beta x. So you might think that is it okay to use in a different way over here? Is either the cos first or sine first? So the answer is yes. So you may use is either one. Is either the first one is cos or sine? It doesn't matter. Okay, so now you need to remember, because of your general solutions is actually involve the value of the lambda that you need to find. So I believe that you have your own way how to find the lambda. So basically the lambda can be found by using the formula negative b plus minus square root b square minus 4ac over 2a. So this is the formula to find lambda, or you may press directly the scientific calculator to get that value of lambda. Okay, let's go to the example. Okay, if you have the example, okay, example 1, let's say you have y double prime minus 7y prime is equal to 0. So the first step that you need to do is, okay, step first is you need to find, okay, find characteristic equation. Okay, so the characteristic equation, you need to transform the derivative or all the terms in the second order differential equation in terms of lambda. So you will have lambda square minus 7 lambda is equal to 0. So for here, I believe that you will know how to find the lambda. Okay, I just assume that you understand to find the lambda, and then the lambda 1 is 0 and lambda 2 is 7. Okay, so from here, your lambda 1 is actually not equal to lambda 2. So your general solution of y(x) is C1 exponent, and take it your lambda first, 0x, plus C2 exponent with your lambda 2, which is 7x. So now you may simplify, and everybody know that every number that having a power with 0 is 1. So you will end up, will have C1 plus C2 exponent 7x. So this is the general solution for this second order differential equation. Okay, let's go to second example over here. Okay, let's say you have what we call it over here is, let's say okay, let's say you have d squared x over dt squared plus 4 dx over dt, and then plus with 4x equal to 0. So it's the similar techniques. What you need to do is the first step, okay, transform into the characteristic equations, and then here equal to 0. So you will end up having your x1 is equal to negative 2, and also your lambda 2 is negative 2. Okay, and then you can make it a conclusion that your roots for this one is lambda 1 is equal to lambda 2, which is, it takes the second case, and then you will have your general solution for x is C1 exponent, you can take it any lambda over here, plus C2. Since here is similar roots, you need to add with another one, which is x dependent variable, which is ct. Ct over here, exponent negative 2t. Okay, so you need to remember that you need to change this one with your independent variable. Okay, so I try to write with a clear one here is c1 exponent negative 2t plus c2t exponent negative 2t. So this is the answer for the similar roots. Okay, so now let's proceed. If you have the equation that having the complex root, for example, if you have y double prime plus 4y is equal to 0. So when you find the roots here, so what you will get here is you will have lambda is equal to 0 plus minus 2i over here. So from this one, you may extract that the complex root having the alpha is equal to 0 and beta is equal to 2. So you will end up having the general solution is yx is equal to, remember that you need to have c1 and then you need to have exponent 0x cos beta x, and then you will have c2 exponent 0x sine 2x. So you simplify over here, you will get c1 cos 2x plus c2 sine 2x. Okay, so what I can tell you for this one, for this section, you need to really understand how to find the roots. So this is the most basic one, because of when you already have the roots, I believe that you can choose the correct general solution that you can create. Right? Thank you.